Good morning, everyone. I am Florian Caillon. Welcome to the Dataviz Challenge webinar. It will happen today and on Thursday. I'm Florian Caillon from MyOcean International. I'm a Capacity Development Officer, and I will be today's moderator for the webinar, as well as Andreia, to which I will leave the mic now for a little introduction.
Hello everyone, and thank you, Florian, for this little presentation of me. So we will talk a bit about the house rules and the guidelines for you guys. So first, for the participant guide, we would like you to make sure that you actually hear us. So you click on a join area on your left lower corner, and you also have a chat on your right hand, and this is the chat box for you to for the greetings, for you to exchange with other participants, but not for your questions. So for that, please use dedicated Q&A section, and we will talk about it on the next slide. So here for your questions, as I said, we have a specific tab on the event page, which is called Q&A. So you can go there and ask your questions there, or you can also scan this QR code, which you have on the slide. And for the Q&A sessions, we will have a Q&A session dedicated to each speaker after the presentation of this speaker. So you will have an opportunity to ask your questions to the speaker that just presented their work. And also, while you on this page of Q&A, you also have a polls section. So that's for you to give your opinion on this webinar. So please feel free to check it out, to fill it out, and also we will send you the survey link after webinar if you prefer to fill it out later. And yeah, we would really appreciate your feedback. So for the next slide, yes, that's the last thing, but not the least is a participant guide, which is basically two tabs. First is the guidelines, and next one is resources. So on this two tabs, you will have useful links for both Copernicus Marine Service platform, and also the links shared by our guest speakers of today. And moving to the agenda. So first of all, you will have a little introduction to Dataviz challenge by Florian, who you already met. And then he will also talk a little more about the Copernicus Marine Service platform itself. Then we'll move to the Ocean State Report Designing for Impact presentation by Andreia Carvalho, who is also from Mercator Ocean, and she's a Communication and Outreach Officer. Then we will have a presentation from Fabrice Messal, who is also from Mercator Ocean International, who is an UX and Capacity Development Manager, and his presentation will be about what the ocean tells us, exploring MyOcean Stories. Then there's a 10 minutes virtual coffee break, so you can have a little rest from all the presentations, all the information, and we'll move to the more like practical part of our webinar with use cases. So the first one will be The Ocean is Turning Sour by Giulia Gravina, who is a freelance graphic designer. Then we will have another freelance data visualization expert, who is Kirk, and he's going to present his data visualization about making vast marine data relatable. And then we'll have a little video of a third speaker for today, because she couldn't be with us today online, so she made a video for you guys. And her presentation is what prevents us from creating maps. It's Chiara Phillips, and she's also a freelance cartographer and GIS solutions engineer. And then, of course, we'll have some remarks about Dataviz challenge, about everything you need to know to move on. And it's going to be by Florian again. So let's start with this very rich agenda. And first is Florian with the Dataviz challenge introduction. So Florian, the floor is yours.
Thank you, Daria, for this introduction. Before we dive into today's session, I'd like to briefly introduce the Dataviz challenge, which is today's main objective, which it is an initiative by the Copernicus Marine Service to explore how marine data can be transformed into clear, engaging, and meaningful visual stories, especially by designers and data visualization practitioners. So Copernicus Marine provides a huge amount of high-quality ocean data used every day by scientists, researchers, and operational users. With this challenge, the objective is to reach new profiles, people who don't necessarily work with marine data today, but who have the skills to make it understandable, visible, and impactful. So in short, the challenge is about connecting ocean science with visual storytelling. So for the challenge in itself, today's event and Thursday's event are designed as a two-step journey. Today, you'll discover use cases, as Daria presented, see how designers work with Copernicus Marine data, and understand the creative process behind data-driven visuals. And on Thursday, the session will be more hands-on and practical with tools, workflows, and also a step-by-step tutorial by a professional of data visualization. After the event, participants who wish to do so can take part in the Dataviz challenge. The principle is simple: create a visualization based on Copernicus Marine data in a format that makes sense for you. It can be static, animated, or interactive. The challenge will run until June the 19th, giving everyone time to explore the data and experiment. The main reward is strong visibility. So the winning visualization will be featured on the cover of the 10th edition of the Ocean State Report, which is the flagship publication of the Copernicus Marine Service, but we'll talk about it more later. And also visibility for not only the winner, but for all selected visuals on Copernicus social medias and website. Before moving on, I just want to highlight two sections of the event website that will be especially useful if you decide to explore Copernicus Marine data or take part in the challenge. So the first one is the resource tab. This is where we've gathered a lot of material to help you get started, explanations about ocean topics, tutorials on how to access and download data, introductions to tools, file formats, and example of data visualizations. So you don't need to know any of this in advance. It's all there to support you step by step. And second is the challenge rules and participation section. This is where you'll find all the practical information about the Dataviz challenge itself, which data are available, how to submit the visualization, the guidelines, the timeline. We'll come back to the challenge in more detail at the end of the event, today's event and Thursday's event. But for now, just keep in mind that everything you need, both to learn and to participate, is already available on the website, and you can explore it at your own pace. So before diving further into the Dataviz challenge, I'd like to give you a short introduction to Copernicus and the Copernicus Marine Service, because this is a data ecosystem you'll be working with during and after the event. The Copernicus is the European Union's Earth observation program. Its core principle is simple but powerful: providing free, open, and reliable environmental data so that it can be reused well beyond the scientific community, including by designers and storytellers. Within Copernicus, the Copernicus Marine Service, which is implemented and operated by MyOcean International, focuses on the ocean. It delivers high-quality, regularly updated data describing the physical ocean, sea ice, and marine ecosystems at global and regional scales. Traditionally, this data is used by scientists and ocean operational for forecasting and decision-making. With the Dataviz challenge, the idea is to open the same data to new forms of use, especially visual storytelling and creative exploration. All Copernicus Marine data comes from a combination of three complementary sources. First is satellite data, which provide global continuous coverage. Second is in situ data. Those are observations from buoys, floats, and research vessels, offering precise local measurements. and ocean models, which assimilate all observation and generate forecasts, analysis, and long reanalysis. All this data covers the global ocean and Europe's key regional seas. Again, you don't need to understand the technical details of these systems. What matters is that the data is scientifically validated, consistent, and comparable across time and space, which makes it a very solid basis for visual work. To make the ocean easier to explore, Copernicus Marine groups variables into three main families. These cover physical processes, marine life and ecosystems, and sea ice. For designers, this means access to a very wide range of possible topics: climate change, marine heat waves, biodiversity, polar regions, extreme events, all from a single coherent data source. All Copernicus Marine data is accessible through a single website. You can browse and preview data online, download data if you need, have access to multiple tools, and decide how deep you want to go. This flexibility is important, especially for creative workflows. In addition to downloading data, you can explore it visually using our online tools available under Ocean Visualization. There are 3 viewers, each designed for different needs. The first one is MyOcean Learn, which is ideal for outreach, education, and simplified exploration. The second is MyOcean Lite, which is perfect for quick interactive viewing of essential ocean variables. And the third is MyOcean Pro, our advanced viewer for more detailed exploration. So you can select specific datasets, compare satellites in situ and model data, perform custom queries, and generate high-resolution graphs. Some of you may use them directly. Others may simply use them as a starting point for inspiration before creating your own visuals with your preferred tools. So today and Thursday, you'll see some of those tools in action. You're not expected to figure everything out on your own. There is a full support ecosystem: tutorials, documentation, a help center, and direct access to the support team. Don't hesitate to explore the help center. And the user corner tab on the website leads you to it. You can reach the help center, and the live chat is also available at all times in the bottom right-hand corner of the website. You can interact with Blue, with the Copernicus Marine AI companion, which answers many questions instantly. And if the automated support is not enough, users can always reach a human expert for personalized help. And just as important, we actively collect feedback from users. It helps us understand how the service is used, what works, what doesn't, and how we can improve it, including for creative and design-oriented users. So in the user corner, again, you can access the user feedback and needs platform, which is a dedicated space for users to share ideas, suggestions, or needs. We also have an annual user survey to improve the service, and to which you can have access by scanning this QR code. And we'll also send a link in the chat. So thank you in advance for your contribution. And last but not least, Mercator Ocean International and the Copernicus Marine Service have launched a new podcast called Decoding the Ocean. The series will explore how ocean science, digital innovation, and free and reliable ocean information have real-world impact. The podcast is available on all podcast platforms. You can have access it by scanning the QR code. And the first episode introduces the fundamental role of the ocean in regulating the climate, supporting biodiversity, and sustaining human activities. And with that, my presentation of the context is finally over. I will leave the mic to Andreia Carvalho, who will speak a little bit more on the Ocean State Report. So, Andreia, the floor is yours.
Thank you, Florian. Hi, everyone. Good morning or good afternoon. Well, no, not yet. Good morning, everyone. Happy to be here. And yes, I will tell you a little bit more about the Ocean State Report. I will start by sharing my screen. Bear with me. Not this one, this one. All right. I hope you see my screen, but not in presentation mode yet. Okay, Yes. Do you see my screen?
Yes.
Just to be sure. Okay, good. Thanks. Yes, so my name is Andreia. I work at Mercator, as Florian introduced me already. And my main role is to oversee projects where we try to convey our scientific information and make it accessible to different audiences, especially to non-scientific audiences. And so today I will tell you a little bit more about the Ocean State Report, which is our annual scientific publication of the Copernicus Marine Service. This is a state-of-the-art reference assessing the natural variability and the changes happening in the ocean, as well as key trends on the main indicators, such as sea surface temperature, ocean heat content, sea level, sea ice cover, and so basically the vital signs of the ocean. And this is an annual cycle that we elaborate every year. So every year we have the contribution, we can count on contributions from more than 100 scientists, mainly from Europe, but also from organizations outside Europe. The first publication we have done was in 2016. So we are currently preparing our 10th edition, which will come out in 2020 in September this year. And that's why one of the reasons we thought of the topic for this data visualization challenge was to include this 10th anniversary in this challenge. And yes, so this is not just a report. This is a reference report for the scientific community on the state of the ocean, basically, or mainly through its long-term assessments, but also it's a reference report for the European Commission, because it tells us more about how the ocean is changing, what is the state right now, new methods that we are learning about, how on to exactly study the ocean. And so all this information can inform policies and different initiatives. So as you can see, it's a quite important piece of information. The challenge lies on turning this complex science and valuable information into something that people can understand and can remember, so they can connect with. And so that's where the Ocean State Report summary comes in. So the rest of my presentation, I'll focus mainly on the summary, and that's also the part of the Ocean State Report where I work the most. And the summary of the report is basically, like the name says, it's a shorter version of the report that focuses on having a clear narrative, structured information, focuses on having a consistent visual identity that can help readers to basically screen the information very quickly, and also with an accessible language to non-scientific communities, mainly targeting policymakers, the media, because they are also a very important vehicle to transfer the information, and the general public, also to create awareness among the general public on the, like I said, state of the ocean, changes that are happening, things that we learn about the ocean each year. So I'll give you a short overview of how the Ocean State Report summary has evolved throughout time. So we're now preparing our 10th edition. So a lot has changed. In the first issues, we sort of defined the structure on how we were going to create the summary, and a structure that we could reproduce every year, and that would make sense also for the content of the report every year. I would say in a second phase, we started to make the complex information more and more accessible to the public. So we started to play around a little bit more with visuals and ways of explaining the science. The latest reports, say the 7th, 8th, and 9th issue, have been focusing more and more on creating more engagement or more impact, or even more through especially a narrative, storytelling, using all the types of, let's say, methods to reach and engage the public. And so for the first years, like I said, we defined the structure of the summary. It was clear from the beginning that we would have to choose a way to present the different information we had, and something that made sense as we define it in the Copernicus Marine Service is the blue, green, and white ocean. Like Florian mentioned, so the type of data we are talking about, if we're talking about the physical components of the ocean, if we're talking about the biogeochemical components or the sea ice components. And so this was a structure that was identified from the very beginning, and that we have been reproducing in every report, every summary since. And so be it focused on the key indicators of each of these types or like sectors, let's say, of the ocean, physical, biogeochemical, and sea ice, or focused on extreme events or new information that we found out from these different sectors. The second phase, so this is an example of the Ocean State Report 5, and it's where we, at least is more identified that things changed slightly, and we started to make a bigger effort on explaining the science in using, for example, metaphors or comparisons that would relate more, people would relate more to those. So, for example, here you have an example of infographic that was created to explain 3 extreme events that happened in Venice in 2019, and to put it in perspective how extreme they were in terms of human size. And a second example you see on the right side is about the Arctic, and about the trends, sea ice trends in the Arctic. This was up to 2020, I believe. And the idea was to explain so how much sea ice we are losing, and in this case, up to 2020. So it was put in comparison to the size of a country. In this case was 6 times. Sorry about that, it's a bit small, maybe for you it's not so easy to see. So here we have a comparison on how much ice has been lost up to 2020, and it was put in comparison to the size of a country. In this case was Germany. So the amount of sea ice lost was 6 times the size of Germany. And on the right side, you have another example of how we explained what happened in a specific region in the Arctic called the Barents Sea, where there was actually an increase in sea ice. And so there was, besides the graph, we also explained, okay, it was due to different factors, and there was an infographic explaining which factors contributed to this increase in sea ice. So you can see these are just a few examples on how we try to make this information more accessible using data visualization, design, different techniques. And the last issues, we have been trying to work more on a stronger narrative or on a storytelling. For example, the latest issue, OSR 9, we have created a narrative for the whole summary. In this one, we focused on the fact that everything is connected, and how the changes we are seeing in the ocean, for example, increasing sea surface temperature, ocean pollution, acidification, all these changes that are happening in the ocean will have an impact in other realms, let's say, be the marine ecosystems, so marine life, habitats, but also in areas that will directly touch human beings, such as the economic sector, the societal sector through fisheries, food availability, etc. And so yes, this was just one of the examples. We tried to make it more impactful. A second, another message we wanted to express in this report was also the triple planetary crisis. This is a term that was put out by the United Nations. I believe it was in 2024. And it relates to climate change, biodiversity loss, and pollution. So the three planetary crises, and how so our message was that these three are currently impacting every basin of the ocean. So we can see that in almost every corner of the ocean, we are seeing this triple planetary crisis. So this is also another quite powerful message we wanted to convey in this report, and it's just another example of messaging. I wanted to give you a few examples of things that I believe, in my opinion, worked quite well in the way we transformed the scientific information into something adapted to the general public. Here on the left, you see two graphs. They are related. They are comparing marine cold spells and marine heat waves. So marine cold spells are events in the ocean where the water is significantly colder than the average, and marine heat waves is the opposite. So temperature of the water is significantly higher than the average. So the idea here was to compare. The original study compares both events since 1990, no, maybe before even, 80s or maybe 70s until 2020. And so the idea was to show how these two events are evolving over time. And so in the summary, we have put them side by side, and we have really highlighted what is changing in terms of frequency, intensity, and area. And yeah, just highlighting also certain information that we wanted, like keywords that we wanted to people to understand, take away from this messaging. And then basically the main message is that marine heat waves are becoming more intense, more frequent, and occupying larger and larger areas of the ocean. And we see almost the exact opposite in terms of marine cold spells. Okay, another example, and I'm almost finishing my presentation. This is an example of an overview of the major outcomes up to 2020. This is in Ocean State Report 6, and it was part of the chapter 1, and it gives an overview of main trends and also many extreme events that happened up to 2020. And as you can see, it's already very good, the fact that it was tried to make it very visible or visual, like with the map, global map, and then an European map. But it also has a lot of information in it. And so for the summary, we have gathered one map only, then with a focus in Europe. And we tried to make it even more more quick in a way for the public to be able to extract information quicker. So using icons and like a sort of a code for people to understand if the trend is increasing, if the trend is decreasing, what kind of extreme event it was. Yeah. I'm almost finishing. Just to conclude my presentation, I just wanted to say that, yeah, we are continuing working. We obviously see an evolution in all the Ocean State Report summaries, and we keep what has been working, and we are continuously trying to improve and not only make science visual and understandable, but also to continue working on more impactful stories and make people understand them, remember the messages, but also care enough to be able to act. Yes, and that's all for me for today. Thank you very much.
Thank you, Andreia, for your presentation. We received a few questions more on the context of the whole webinar. I will start sharing them. Yes. So the first question is if participants will receive a certification of participation for attending the Dataviz challenge webinar, and the answer is yes, you will receive it right after the second session of the webinar. And then we have a question on the Ocean State report. Beyond the website, where is it disseminated or published? Maybe Andreia, you can.
So the Ocean State report is published in the State of the Planet journal. It's a scientific journal. We published it in there, and then we disseminated. So it's available freely to everyone who wants to access the report. The summary and the report, we like you say, we make it available through our websites. You can download it. You can access it. That's it.
Okay, nice. And do we have an idea of audience it reaches?
The audience it reaches. The report or the summary, or both, I guess.
Both, yeah.
Yeah. I assume the report is more definitely scientists. The summary, the Commission, the European Commission definitely accesses the Ocean State Report summary. The media as well. Last year we had a lot of coverage from the media. A lot of media outlets reported on, wrote articles about some of the findings from the report. And I hope the general public, we don't have so much data in that sense, but we do have, some numbers on accesses on the website and stuff, but it's hard to know exactly in more detail.
Goodness. Our second question is, can we use other data sets in addition to Copernicus data? I guess it's for the Dataviz challenge, so I will take this question. So the visualizations should primarily focus on the Copernicus Marine data. The data sets are extremely rich and consistent, and they are sufficient on their own to support strong and meaningful ocean visualization. But other external data sets, for example, on fauna or socioeconomics, can also be used as complementary context. But it should not replace or duplicate the ocean data, which should come from the Copernicus Marine. Our next question is, so this should focus on static visualizations. Yes. As I said, the format is up to you. It can be static or anything. It can be also interactive. Of course, for the Ocean State report cover, we will have to adapt it so that it fits a static version. But the Dataviz can also be moving or can be PDF, videos, interactive, as I said. So the format is free. And then we'll anyway get in touch with the winning Dataviz and author to adapt it to the Ocean State report cover. For the next question, we have, what tools or software are we going to use for the Dataviz challenge? In terms of ocean data and Copernicus tools, we will present them to you throughout the 2 days event. And as I said, you have all the resources needed that are available on the website. In terms of data visualization and tools like artistic tools, these are open and up to you. You can use any software that you are used to for the Dataviz creation. Then we have a question on if we have a template or guidelines for the Dataviz challenge. The template is up to you again. The format is really free. All we want to do is to let you have access to very rich data, as I said, and explore it and have fun with it to create a meaningful and impactful story. And for the guidelines, everything is available again on the website, more on the, I will anyway have a longer presentation at the end of today's session, but for the timeline, the formats that we accept, how to submit it, and all these information is available on the event website. Is there a limit on the number of people in a team? For the Dataviz challenge, no. We will need a single contact person for anything that is related to the challenge, but you can work as teams for creating a visualization. But the next question is, will we be learning on how to work on the datasets hands-on during the sessions? Yes. So, as I said today, we have more presentations on use cases of Dataviz experts that use the data and created a visualization with it. But on Thursday, we'll have a more detailed presentation on the tools that you can use, how to use the tools that are provided by Copernicus Marine Service, especially the MyOcean Pro, where you can visualize the products and download it. And then we have a step-by-step tutorial by Catalina Hildebrandt, who is also a freelance designer, that will present how she created her visualization step-by-step, which tools she used, which softwares, etc. And we will also have, in the resources tab again, all the information. You have a presentation by Chiara Phillips, who presented last year a step-by-step tutorial, again, with all the tools she used. So you have plenty of resources to help you. Like, we take care of the technical part. You can only focus on exploring and creating visual stories. The next question is, were there previous rounds of competition before? If there, can I find a winning visualization for inspiration? Yes, I a bit spoiled the answer with the previous question. There was a Dataviz challenge last year. The Dataviz contest was a bit different because it was not for the Ocean State Report cover, but it was displayed in the UNOC, so the ocean. I don't have the specific words for UNOC, but it's an international.
United Nations Ocean Conference.
Yes, this one that happened in East last year. And the winning visualization was displayed, and I will make available the link to the previous visualization on the website also. We have a gallery. Regarding the visual design, are we allowed to use external design assets or illustrations, for instance, from platform like Canva, to support the narrative, or must every element be custom made? No, you can use like every resources that you have at your disposal. For the data, it's Copernicus Marine Service sourced. Otherwise, it's available to use other illustrations that you may find, as well as photos. Is there any specific condition about the design? Can we design spatial maps? Yes. Again, the design is really up to you. Like, I don't know if it's like specific condition on format, like ratio, but there's not. And if it's more like condition on the more administrative part, you will have all the details in the terms in the submission process. Is there a specific geographical preference for the case study? Would a deep dive into a specific national maritime area be as competitive as a global scale visualization? No. Every geographical area that is of interest to you is open as long as it's on the ocean. There is not the specific area, not like the global visualization will not be preferred to very local visualization for winning designs. As I said, there's like one winning design for the cover of the Ocean State Report, but all visualizations will be, like selected visualizations will be displayed on the website of the Copernicus Marine Service and shared on the socials also of Copernicus Marine Service and Mercator. Does the Dataviz need to tell a specific story, or can it be just artistic based on Copernicus Marine data? We are search for storytelling, like on specific marine phenomena, but it can also be artistic based. Like we don't search for scientific perfection, let's say. The idea is to transform the data which is raw on Copernicus Marine Service and tell a story with it. So like if we visualize a specific like marine heat wave or the ice extent, how it moves, that for sure very interesting for users and for the public, the general public. And it can also be very artistic based on just a picture of something that is marine phenomena. We have like the background of the Dataviz challenge, which is the phytoplankton bloom. It's just it tells a story, but it's also very visually appealing. So we don't have specific requirements on what it has to portray. And our last question is, can we use this tool for riverine quality monitoring for inland waters? I'm not sure I understand this question, but for the Copernicus Marine Service, we only have data from the ocean, so no inland waters. And with that, I think we can go to our next speaker, who will present the MyOcean Stories.
Hello, Florian.
Yes.
Hello, everyone.
The floor is yours.
Okay, thank you. Thank you very much. So my name is Fabrice Messal. I work at Mercator Ocean International. I was invited to present you MyOcean Stories, how you can create stories, and my experience using mostly tools for live demos. So it's a bit aside of what you have to do, but maybe interesting for you to know how we deal with different targets, different audiences, and with the different variables, different scientific knowledge we want to share with the general public and other kind of audiences. So let me share my screen and tell me if it's okay for you. Okay. So we already talked about the importance of having a story to tell. This is a list of tasks we usually work on, whether consciously or unconsciously, to create our stories and to create this narrative. I'm pretty sure that Catalina Hildebrand tomorrow will go through these points to share her experience. To have an idea of the topic, interesting topics you can use on Copernicus Marine Service. We have the explainers. This is a section on the website you can find to have scientific knowledge. You can use with the data to create your stories. You can refer to the news. What is important for the public to know about the ocean, considering the threats or the benefits of the ocean, the role of the ocean in our daily life. but I would like to specifically highlight 2 bullets on this list. Use clear and engaging visuals, and create an emotional or human connection. Because from my experience, this is a very, very important. Sometimes when you talk about scientists, only data matters, but engaging visuals with some touch of art are a way to create an emotional connection with people. So that's how we used to design our applications, our animations, maps, with this artistic flair, because we think it matters. So I would like to share some example of tools I'm using for live demo. In our multiple communication and outreach activities, we worked with different targets. I would like to focus on these two: the general public and the people working on policy, because it's our role at Mercator Ocean as the implementer of the Copernicus Marine Service, also to convince the policy people that science can help to take good decisions and take actions. The targets are different, with different skills, different level of knowledge. So you can discuss the same topic with them, but you know that you can use the same tools also, but you know that you need to adapt the narrative sometimes to be sure that you will touch the target audience. So I will share now four examples of tools I'm using for live demos. The first one is the MyOcean Learn. This is one of the many tools, viewer tools we have on the Copernicus Marine Service to deal with outreach activity and to share beautiful animations with the general public. So we have chosen key variables, and we just dive into these nice animations. You can zoom in, zoom out. So you have few information on the data itself, to know why is it important to monitor the temperature of the water, or why it is important to monitor the currents, etc., etc. And with example of use cases, how the data is used by the private sector or the research institutions to create new services or to make new researches. So this is the first tool. The other one is a tool we have developed 2 years ago. We call it MyOcean Stories. This is a tool. It allows us to create stories and to with different chapters, different steps, with a longer narrative. You can go through very complex, sometimes complex subtopics, but you take time to put the context, to explain what is available, the data we use, in which purpose, in order to, at the end, give some key messages and impact messages to the audience. We used to develop this tool in different instances for different services. My colleague Andreia is working on a version dedicated to the Copernicus Marine Service. This one is dedicated to the European digital twin of the ocean. It's just to show you that we put a lot of energy to make something beautiful, something nice, to really hook the audience during live demo on a big screen when we participate to conference with a big booth and big screen. So as you can see, we put some efforts to have this nice 3D globes. You can access to videos. You can dive into different variables with different kind of representations. It can be animations. It can be only maps. You can put some points of interest. So it's very useful for us to put the stage and starting discussions with the public and to play with this kind of tool to make our talk more impactful. The third one is a dedicated application on a specific topic, which is the turtle swimways. So we have a scientist here working on the behavior of the turtles. Is able to make models from that, knowing what kind of temperatures they prefer, the impact of the water velocity on their ways, and because they are looking for food. So we know exactly how to reproduce this kind of behavior. And so what you can see here is really the swimways of the virtual turtles. So it's 150 virtual turtles from Nesting Beach in Costa Rica, starting their journey in the Pacific Ocean. So again, you can see the quality of the design of what the designer have created, and thanks to that, we are able to tell the story of the threat of bycatch of the turtle by fishing boats in this region, and how policy can make the difference by, for example, closing fishing activities during certain periods and see directly the impact. So this is a kind of web application we use in the live demo for conference with very simple story. If we need, we have different tabs, different steps to tell the story, and from the context to the key messages at the end. But we work a lot on the design and make something beautiful to hook again the audience. And last but not least, the MyOcean Pro viewer. This is a viewer you can use to dive into the catalog of data from the Copernicus Marine Service. Okay, it's maybe at the first sight complex because you have all the data available with all the parameters and the different regions, etc., etc. But you can use filters to find the data, relevant data you want to illustrate your topic. And when I don't have applications, specific application on one topic, and I want to create a quick story to tell, I use the MyOcean Pro. This is a way for you also to test your scenario, to test your story with the data, to make a first round of testing, because you can play with the different parameters, the color palette and the boundaries of all the color palette and the different layers, so you can adjust. And at the end, you can use the data with your own tool to process this data and make something more beautiful, more catchy. So, for example, it was a scenario, a quick story about the Duke Gap, Greenland, Iceland, UK GAP, which is a strategic route for navigation. It was for a conference about space and security. So it was to highlight the fact that thanks to data from the Copernicus Marine Service and the seawater temperature and the seawater salinity, we are able to provide the core information to produce, for example, acoustic information, which is very used to monitor this kind of strategic routes, and specifically to listen to the submarines who are getting these routes. So I have finished my presentation. I don't know if we have time for a question or.
Thank you, Fabrice, for this presentation.
I will moderate the questions for Fabrice, and we received
I don't know
some.
if it was planned to have questions for.
Yeah, of course. Of course it was. Yeah, we have a couple of questions, and of course, for our participants, if you have more, please don't hesitate to use the Q&A section for that. Should I share my screen, Florian, or are you gonna do that?
I have it.
Yeah, okay. Okay, I just didn't know if you were on it. So for the first question, it's can you share links to these examples? And I assume that, yeah, we didn't have these links, so.
Yes, I can share the links after the meetings, after the training workshop.
Okay, great. Then we will upload them to the resources tab on the page. And the next question is, can we allowed to do data forecasting or simulations?
Maybe it's for you, Florian, no? Because if it's about the Dataviz challenge.
I'm not sure if it's about data challenge or is it about the tool which you're using, or maybe both.
Okay, so I think for the challenge, the answer will be no. But for to tell the story, yes, you are free to use our data to create your own simulations, and if you want to tell a story, but be careful to the scientific validation of your simulations.
Yep. The next question is, what additional methods or evidence-based approaches can be used to map marine life in regions such as Greenland beyond the commonly used techniques and functions? And furthermore, how reliable and accurate is the data generated through these tools, particularly in remote and complex marine environments? It's a very long question.
Yeah. So for the second part about the accuracy of the data, you will see on the catalog of the Copernicus Marine Data, you have access to all the documents relative to the quality of the data and the validation of this data. So you can go to check, but all the data provided by the Copernicus Marine Service are scientifically validated and qualified before to be spread to the public. So this is very important for us, and this mandatory. What additional methods of evidence-based stuff? Yeah, marine life in this region. Yeah, you can use the chlorophyll, all the data links to chlorophyll, phytoplankton, ocean color. Yeah.
Okay, thank you. I think that was the last question. So
yes.
Okay, well, but again, if there's gonna be other questions that will appear later. We will answer to them after the event, and we'll share the answers with the participants on the website.
Okay.
Yeah, and we have also lots of questions on the challenge. We'll address them at the end of today's session because we have a more detailed presentation of the challenge that will come.
Okay, so thank you, Fabrice.
Thank you. Thank you very much. Have a nice day.
Thank you.
Thank you, Florian.
And now we will have a short coffee break. It was supposed to be a bit longer, but since we are in a bit of we're a bit late with all the questions you have for us. So we'll be back by 11:05, I think. Florian, you think it's okay, or yeah?
Yes.
So like a couple of minutes for you guys to just brief out a bit, and we will be back with our first use case presentation in 3 minutes. So yeah, see you. And we are back. It was a very, very short break, but we are moving on with our next presentation, and it's going to be by Giulia Gravina. Giulia, you hear us? You see us? And
yes, I'm going to try and share my screen now.
Yep.
Hopefully it will work. Okay. Is it working?
Yes. Yes, it's
perfect.
Good.
So
yeah.
Thank you so much, Daria, and hello, everyone. I'm very happy to be here. I'm very excited to talk about this project. What I'm going to be doing is I'm going to go over the way that I made this data visualization. So before we do that, a little bit about myself, because I'm a narcissist. No, not because of that, but because I think it's important to know where I'm looking at this from. And my name is Giulia. I'm a graphic designer based in Italy, and I specialize in data visualization. So basically, I specialize in turning stuff like this, which is raw data, very difficult to understand for regular people, but also scientists, everyone that looks at something that is so overwhelming as a data table is probably not drawn to the information inside. So my job is to turn stuff like this into stuff like this, visually appealing presentations of data. In this case, you are seeing some posters, so static visualizations, but of course, visualizations can be animated as well. And in this specific case, the one that I showed you earlier also has an animated version, but we'll talk about this in due time. Now, I want to take a little step back and go back to my presentation and emphasize one fact about me, which is that I am a graphic designer and therefore I'm not a scientist. I believe that this is important to point out because our job as information designers, as people that translate stuff that is sort of already there in the world into stories that people care about and people can look at and derive information from, is a very important job, and it is a job of responsibility. It is our precise responsibility as cultural operators, as graphic designers, information designers, to have respect for this raw material, which is data that has been assembled and gathered by people that make of this their sort of job and life. And we need to be aware that we have to use this data in a responsible manner. We need to use this data in a conscious and aware manner. We need to understand it before we can start turning it into something that's nice and sparkly and that looks good. So I think this is very important to emphasize, especially because we tend to think of data as something that is objective and that can only tell one story. But I always like to start my presentations about data visualization with this quote by Ronald Coase, which is, if you torture the data long enough, it will confess to anything. And I think this is very important, not to say that data is that visualizing data is necessarily a manipulatory sort of tactic to drive a specific story, but actually it's the complete opposite. I think that since data in itself sort of can be looked at from many different perspectives, it is our job as designers and communicators to find the story that we want to tell, be aware that we are telling a specific story, and be honest in our treatment of data. So I think this is a very important premise before we start talking about actually using this data, employing this data to create stories and narratives. And the way that I usually work with data is this. Now, this is a very simplified, linear model of how I go about creating data visualizations. And but I think it's a very good starting point. It's a very good model to have in mind. And I'm going to go through it a bit more in detail later on. But basically, you have to start with the idea. That's what I was talking about. You have to start with a clear idea of what you want to tell, of the story you want to tell, and a clear understanding of this idea, especially when you're working with data which is scientific, like this, like the data sets that you will have at your disposal in this project. Then, once you have the idea, once you know what it is that you want people to care about, you need to gather the data set. You need to format it in a way that makes it possible for you to visualize it, which is the most tedious bit probably, but it's very, very important. Then we go on to the model. So now that you have the data, you need to find a way for each data point to be visualized in a way that makes sense, because not every single variable can be visualized the same way. And then once you have done all of this labor, it's finally time to put everything into graphics, which is the most fun part, admittedly, but also it is not a silly part. It's actually very, very important, because once you have a story that you want to tell, you need to make people care about that story. And we live in a very visual sort of digital environment where we are constantly bombarded by visual information. And so making our visualization look good is the first step, the first barrier that you need to surpass so that people will care enough to look at what you have made. And so I've lied to you a little bit, because these arrows are a bit deceitful. In fact, the model is actually more complex than this. You will go back and forth between all of these steps. But what's important is that you will always need to start with the idea. And how do you get an idea? Like, it's easier said than done. How do you stimulate your brain to produce something that counts as an idea and that makes sense? Well, I cannot answer this for everybody, but for me, I usually start exploring. I just go where my curiosity drives me. And I think that you will find a lot of information, a very rich collection of data sets in the Copernicus Marine Data Store, which is the place where I started from. And so I started exploring. It was a bit overwhelming at first, I'm not gonna lie, because there is so much data and so much information to be to sort of absorb and understand. So I looked at some of the ocean products that you can download, and I figured out how to visualize it, how to download it, and how to sort of get a preview of the data with tools such as MyOcean Pro, which we already talked about, and I will not dive too deeply into it, because I think that you will have specific sessions on this tool on Thursday. But this was very instrumental. This was very important for me to understand this data and how it could be visualized. And then I also dug deeper and found more specific data sets and stories in the data. And once I had everything sort of laid out, I finally found my idea. And my idea was that of ocean acidification, or at least the story that I wanted to tell was that of ocean acidification, which is something that probably if you if you are a scientist, if you work with marine data all the time, you take for granted as something that is obvious. It's something that, of course, is happening. How could you not know that? But I believe that if you are making a visualization for common people, which are the people that matter most, because there is a lot of common people that can have a huge impact when you add up all of the things that we can do together. Now, if you take that as your target, you need to sort of understand that most people don't even know about this. And I think ocean acidification as a story, like the reason that I chose it, is that I think it's very powerful. It's very visceral already as a thing. Like, if you think about it, think about being a fish and your entire environment is becoming sour, even more acidic by the year. That is something that you can picture. That is something that feels very, very visceral, very much like an emergency, which it is part of, because of course the story is always more complex than this. So I chose this, which also has the advantage of already having sort of a color palette associated with it, because if I say the word acid in your brain, a specific color I'm sure pops up, which is green, lime green, yellows. And so I could already picture this visualization in my mind. And then, of course, since I said that I am not a scientist, I'm a graphic designer, I relied very much on documents such as the Ocean State Report to sort of inform myself and become acquainted with what the subject of my data visualization was, what it was about, what it was causing, and what it was related to, what it is related to. It is something that's still going on, of course. So I think it's very, very important in this phase to get acquainted with the subject that you're going to be talking about. And so I had my idea. Now I had to find the data set. And I'm not going to spend too much time on this because, of course, it's probably the biggest part of making a data visualization, taking care of building a data set. The only thing I'm going to say is that, there are a lot of resources available on the Copernicus Marine Service website, which were instrumental, very, very important for me, because I was not used to working with NetCDF data. So I had to, well, actually, I did convert some of it to CSV. In the end, I did not end up using the converted data for my visualization because I relied on the MyOcean Pro web app, which was very, very useful. I found it very, very useful. But what I'm trying to say is that even for me, this was very intimidating. This was something that at first I had a bit of trouble with, but it is important to sort of push through, and the resources are there, they are available, and you will find a way to tell your story. That's what I'm trying to say. So yeah, I'm saying this because I am used to working with CSV data. So basically tables. And at the end of the day, I was able to find this data. I was able to create multiple tables that I could work with. And I could finally go on to the model phase. Now, what do I mean when I say model? Well, when you are working with data and data visualization, you are relying on visual models that are already embedded in people's experience. Now, some of them might be more familiar. For example, a simple line graph is something that people already know how to read. So if you create, we are talking, of course, about sort of a European Western visual culture, but if you create a line and you put a graph on top of it, people already know that they need to read that line from left to right, and that the line is gonna proceed in chronological order. So you can rely on models that are already in people's mind. And of course, you can rely on models that are a bit more complex and interesting, and you can even make your own. I am a staunch believer of the fact that you need to start working on paper. I always sketch out my ideas with pen and paper at first. And of course, it's going to look completely different from the final result. But I think it's very important to start thinking with data physically, let's say, by sketching it out and try out different ideas and visual representations. And once you have all of that, I use a bunch of different software to create my visualizations, but one that I feel like it's a good idea to introduce is row graphs. I will not go over it in detail. I will just say that it's a tool that I use a lot because it's completely browser-based, it's completely free to use, and it's also quite intuitive and simple. You just, in this case, I'm using a sample data set, but you can paste your data, of course, and you choose your visualization method, you drop all of your data fields into the categories, and you get, and this is very important, an SVG file, which is a vector format, which is what I'm used to working with. Because once we take the next step and we get to the graphics, now this is where the fun begins. And this is where it is very important to have vector graphs to work with, because these vector graphs are the ones that you're going to be customizing and turning into captivating and appealing visual representations, which is what I did. I usually work with Adobe Illustrator personally. So I made this spread, which I then animated using a combination of Adobe After Effects and MyOcean Pro. I downloaded the high resolution GIFs from there, and I got this final result, which has, as I've said, an animated version where you can see that this acidification part, this graph about the pH dropping is related to the timeline of the map, which shows how the ocean is changing with this drop in pH. And I want to take a second, I don't know if I'm going too long, but I want to take a second to look at least one of the parts of this visualization, which has a bunch of different parts, and it's this one. Now, whereas with something like the pH graph, I stayed in the comfort zone of a simple line graph. It is customized, it is made more appealing with graphics, but at the end of the day, this is a line graph. There is nothing weird going on here. It's something very intuitive. In this case, though, I decided to take a different route. So the data here, as you can see, it's about the carbon, the amount of carbon that we are dumping into the sea each year. And I could have gone with a simple line graph here as well. I could have put all of these years in order from 1985 to 2023. But I thought that visualizing this sort of data in that way would sort of lead people, as it has led me many times, to disregard the previous year, because you are saying, okay, last year we, we dumped 2 billion kilograms of carbon. This year we dumped 3, so it's worse. We should go back to 2. No, actually, each year that we dump even a tiny fraction of carbon into the sea will add up. So I tried to give weight to these amounts so that you can actually tell that year by year we're not just starting over with the counter. We are actually adding things up on top of each other. And another big part of the visualization, of course, was the maps, which, as I said, I used the MyOcean Pro tool to make. And then I put everything together and sort of created a visual narrative that takes you through that allows you to explore this problem, starting with what the problem is. So what is acidification, why it's happening, and then what kind of impacts it has on the ecosystem. And then referencing back the Ocean State Report, I also decided to talk a little bit about the triple threat of warming, acidification, and sea level rise. So these three things coming together to sort of exacerbate the problem. So I hope I didn't take up too much time. Thank you so much for listening to me. If you are interested, you will have this presentation and you can look at it more closely on Behance. And I think that's it. I'm just going to let this go the whole way so that you can see it. And thank you so much for listening to me.
Thank you,
Okay.
Giulia, for your presentation. We have a few questions for you here. The first one is on tools that you used. What alternative tools or platforms are you using for graphic designs and data visualization apart from MyOcean Pro? And additionally, do these tools support layer-based data representation? And is it possible to monitor or integrate the data using GPS-based tracking systems?
Okay, so to answer this, well, I've used MyOcean Pro, of course. I've used raw graphs and Illustrator, and some of the graphics. I think, yeah, for this visualization, I only used raw graphs, MyOcean Pro, and then I put everything together in Illustrator myself. I did tinker with QGIS, but it's not my preferred sort of platform to use to make data visualization. And in the case of raw graphs, of course, it does not integrate GPS-based tracking systems. I'm trying to think. I don't think I can recommend anything that really responds to the necessity that this question is presenting. But I had, okay, let me check. Is it possible to know? I'm not sure what you mean by layer-based data representation.
I believe it's something like QGIS, for example, that you can layer.
Oh, okay, yeah. Yeah, in that case, honestly, QGIS is the only tool that I know of that responds to this necessity. But in my case, like I used mostly Illustrator, raw graphs. Sometimes, like in the past, I've used Tableau Public, which has a free version as well. And yeah, everything else was just visual manipulation that I did with Adobe Illustrator and After Effects.
Very nice. Thank you for your answer. Our next question is about your approach to choosing your color palette and how you manage accessibility, such as vision disabilities for your designs.
This is a very good question. So in terms of choosing a color palette, well, it depends. In this case, as I've briefly mentioned, I think that I was able to rely on visual coordinates that already exist in people's minds, because since I was visualizing something such as acidity, I could rely on the sort of stereotype, let's say like this, on the already present in people's minds visual stereotype that acid is green, which is something that you can do to sort of soften the load, the cognitive load that it takes to look at a visualization. Because if you are relying on something that people sort of understand subconsciously, because they don't have to think about the meaning of the color, because they already know the meaning of the color, this is going to allow you to free up some cognitive space to think deeply about the more complex part of the visualization. So in this case, I relied on that assumption that already exists in people's minds. And in terms of managing accessibility, in data visualization, you can do this in two ways, because color is one of the most powerful visual coordinates that you can use, because it's very immediate for people that don't have vision disabilities. It's very, very immediate, and it communicates. It's the visual variable that comes out first. So one way to obviate to this problem is to use tools that simulate daltonism, for example, and check that the contrast is good enough for everybody. Of course, someone who has daltonism will see it differently, but the most important thing is legibility. So it's important that it's still legible. So this is one way in which you can go about it. And the other way, which of course you can do both, is to express the same data with two different visual variables. So for example, the amount of carbon, like to take an actual example from this visualization, the amount of carbon is coded not just as the transparency of the bubbles, so the color of the bubbles, but also as the diameter. So you have two variables that signify the same thing, so that even if you can't really detect the color as well, you can still get the information with a different visual variable. So these are two ways you can go about it.
Nice, thank you. As we are running a bit late, I think we'll have time for one last question, but then we'll have a post-event report that will be sent to all the participants, where we'll answer all the other questions that you'll have. So for our last questions, what are the limiting factors of row graphs?
Well, row graphs is not an all-encompassing tool. It's very good at doing very specific things. So the limiting factors, I would say, are that if you are not proficient in designing with Illustrator, you will not get a really good graphics out of it, because it is not meant to create a finalized data visualization. So row graphs is sort of a starting point to build a visualization that actually looks good. So this is one of the limits that it has, but it's also one of the strengths that it has, because it allows you to get this raw information that is already mathematically and scientifically correctly represented, and then make it beautiful yourself. So this is one. Of course, row graphs only has some chart options. You can actually add your own if you are proficient with programming. You can actually create your own scripts to run on row graphs. And yeah, in terms of this specific challenge, the most limiting factor, I think, is that it cannot visualize net CDF data. Very, very simply, this is the most limiting factor. But I don't think that you need to rely solely on that type of data to create a compelling and interesting visualization. So I hope this answers your question.
Thank you, Giulia, for answering those questions, and thank you very much for your presentation and design. We'll transfer you all the questions that we received, and I will add them to the post-event report. We will now move on to our next speaker, who's Andy Kirk. The floor is yours, Andy.
Thank you, Florian, and thank you also, Giulia, for a brilliant talk. Hopefully, as you'll see in the next 15 minutes, a very kind of complementary talk to what I'm going to go through. So let me just bring up my slide deck. Making vast marine data relatable. So this is work that myself and my colleague Gravina, who couldn't join me for the talk today, worked on. And it's the story really of the next 15 minutes of how we got from this kind invitation from Daria a few weeks ago to a finished piece of work that you see here. So what's the story between those two endpoints? Similar to what Giulia articulated, with a perfect context that I echo completely, there is so much going on with this challenge. First of all, there are so many existing visualizations in the various products that the Copernicus Marine Service offers. Brilliant tools, some wonderful animated and interactive visualizations that already exist. So when I started this challenge, what's the point in me trying to recreate what's already been done and already been done well and probably better than I can do myself? There's so much data to explore. Again, as Giulia mentioned, and Fabrice, the product page is this, I want to try and avoid a pun, but it's a vast ocean of data. So many different topics, metrics, variables. And the challenge with this as a non-marine biologist, a non-domain expert, is where to start. And just because you have access to data, even access to data that's been curated, it doesn't necessarily mean that you as the person looking at data have the correct curiosities to get the most out of that data. And so much has been done before by people who are better placed than I as an individual to know what's interesting analysis, to know what is relevant, to know what is significant and what all this means. So the challenge that I encountered with this was to try and reduce the problem or reduce the opportunity. The thing about the ocean, about water, about the sea, is our relationship with it is quite abstract. It's quite detached. Our concept of place is usually more about land, towns, cities, places that we visit on land. Not so the places at sea, because so little of this ocean has ever been seen, witnessed, visited, or explored. So when we first started this project, and we only had, I would guess, looking back, about 3 days to try and work through this challenge, we had to find a rapid way to make sense of how do we relate to this subject. So we thought about ideas for places that are relatable at sea. Maybe it's places we've traveled, places where we've lived, or at least places near where we've lived because we don't live at sea. Maybe there are places of note, of notable kind of characteristics, or just even the extremes. But what we ended up landing on was the round the world yacht race. We're not yacht people. I come from a part of the UK that is as far away from the sea as you can get in the UK. But the Clipper Round the World Yacht Race gave us an architecture. It gave us these anchor points at sea around the world in a relatively evenly spread layout that could give us something to, as Giulia mentioned, to sort of tell a story, to find a story narrative. The Round the World Yacht Race is based on 8 legs, and the 8 legs are comprised of 13 stages or 13 mini races within. And these are all, naturally, coastal locations, but spread across the world. So we use this as our anchor point. What are the key marine characteristics at each round the world stage? So, 13 stages, 13 locations spread across the world. And across the race agenda, the race takes place or is held or is launched, let's say, from these locations at different times across the year, commencing in August of last year, going right the way through to July of this year. The question we were asking ourselves was, if we were yacht people, either in these races or maybe watching these races, what are the variables that affect or have an impact on yacht racing? So this involves a little bit of research. So we put this into Google, and I would always stress, don't accept the immediate AI overview, because the information provided came from the British Horse Racing Authority. I don't think they're the people we want to know about what affects yacht racing. But nevertheless, after a bit of investigation, a bit of quick research as non-experts about yachting, we were able to find and cross-reference with the availability on the Copernicus Marine site 8 variables that it's fair to say have some impact on the conditions, the characteristics of yacht racing. And so these 8 variables, and they have different levels of impact: seawater velocity, the swell, the wave swell height, the periodic nature of those waves, the temperature, the salinity, the density. So I think that affects how well you can kind of glide your yacht through the water, the depth, and the wind. So although a yacht person in the crowd today might say, no, those are not the 8 that matter, these are the 8 that we could find in the time given. And the 3 products that I've listed above are where those different data sources came from. Now, the next thing to do was to choose a when, because we've got these different points in the year when the race takes place, but the data in the site, in the MyOcean Pros we get into very shortly, doesn't necessarily go into the current date and clearly doesn't go into the future. So what we did was take an equivalent date 1 year before to say, well, although it's not the exact same year, at the same point in the year, you can imagine the similar conditions. And we could use that all the way through, apart from Scotland, Oban, for which the 19th of July 2025 went beyond the maximum data available. So we took it to the latest possible. We asked a question ourselves of, could we compare the data as it was then with a point in time in history to see how it's changed? And although there was some data available, it wasn't complete across all these different metrics for a point in time, maybe 5 years ago or 10 years ago, to give us a wider vantage point to see if change has taken place. But it also felt that it wasn't the most necessary angle of analysis to pursue. So we considered it and then we abandoned it. Now, next up, we got some point coordinates for all these locations. And the locations that we took were to basically sort of come away from the coast, about 1 kilometre in most cases, to see what metrics and what measurements were available. Now, in many cases, as we zoom into the site here, you've got the 8 variables listed, there were some blanks because we weren't deep enough into the waters to have consistent measurements. So rather than using point coordinates, we used regions or area coordinates from the MyOcean Pro tool. So we drew some arbitrary areas as consistently in their area and dimensions as possible to capture the most immediate waters that the yacht race would enter when they leave the port or the harbours. So a kind of a good enough approximation of what the conditions would be immediately. Now, getting the data. And this is about being pragmatic. So using the tool to bring up these captions, by selecting the date, we have the tooltips with the data values at each location or each area. I turned off the max and the mins and just left ourselves with the average, the typical value. I then very did a screen grab, opened up that screen grab, highlighted all the text, pasted that into Google Sheets, and then transposed it into the emerging table. Not the most elegant solution, not the most repeatable solution, but when you are limited in time, whatever works, works. So be pragmatic. Build all the data for all the variables, for all the locations, and then we move on to the design. Because what we were looking to do was to show the characteristics of each location on the round the world yacht race across these different metrics. As I said, so many existing examples are already available in terms of animated and interactive spatial analyses. What we were moving towards was a static place analysis. We used a map, but only to give spatial context for where each of these yacht race locations are. So although it is on a map, it's not necessarily spatial analysis. We use the map projection just to give a sense of the where, and we use the Winkle triple projection to minimize the sort of spatial distortions at this kind of global view. Choosing the right chart, as Giulia mentioned, the models. What's the right archetype, the right chart type to show the analysis that you're trying to portray? There are so many options out there. We were looking at categorical analysis to compare the values across these different metrics for each location. There were a few options that we could consider. And in the end, we settled on this kind of combined bar chart and dot plot. By taking all the data that we collected, we normalized it so we could compare across all these 13 locations whether these individual locations are higher or lower compared to the others, and also above or below average. So these dot plots, these bar chart dot plots, give us a quick profile view of each location and help us to sort of see what are the kind of characteristics in that part of the world when you're entering the yacht race. We would have liked to offer more, maybe some further context about, is this good or bad? Is this going to lead to a challenging leg of the race or not? But again, our lack of domain expertise, not just about the metrics, but about the sport, prevented us going much further with that. The colours, so again, Giulia was asked about the colours. In this case, we use the colours that corresponded to the yacht race kind of established colour guidelines. They were there for more decorative reasons rather than to establish good or bad or high or low values, but just to create that distinction and a degree of aesthetic quality across the map itself. We included explanations about the variables, about the individual metrics. So rather than just having the labels in those dot plot profiles that are quite brief, hopefully self-explanatory enough, we wanted a bit more information on the left-hand side, and also to clarify the basis of the normalizations and also the rationale behind the data dates that had been used. Now, this was a static work. We could imagine this being transported to an interactive, maybe something like a live version wherever you are. If you're a yacht team, you can see where you are. You can look at the trajectory of your route and see what's coming up or where you've been before. Maybe as a race follower, you can again sort of track the conditions that each race participant is taking place or experiencing at this moment in time or going forward. And the routes do give us that chance, especially with the Ocean Pro viewer, to log a route and to sort of create a profile, almost like a cross-section of the waters that they're facing. So, in a nutshell, that's how we attempted, in a short amount of time, with a limited amount of knowledge about the subject, to make this vast marine data set a bit more relatable. Thank you very much.
Thank you, Andy. Thank you. It was a very, very great presentation, very nice visualization. And I assume that all the participants were very into your presentation because we don't have any question right now. I think we were following really with lots of attention. So I think we have some question. Well, I don't know, Florian, you want to share the screen, or we have one question, but it's not really for you, Andy, and we have another one, and I think we will answer this one. And yeah, for participants, if you have some questions, so don't hesitate. Right now is the best time to do so. So the question is, I'm very interested in the probability aspect of data analysis. Did you at all examine among those variables if any of them greatly impacted the race and thus a change could guarantee a win to a certain percentage? And what were some considerations you kept in mind while deciding the charts?
Yeah, I mean, that's a great question, and certainly something that we would have liked to have considered. given more time and opportunity and you know, kind of expertise in how to find this out. But yes, if you were turning this into a much more rigorous research process, and certainly if you, let's imagine you were a yacht race team and you're a sports scientist or a data scientist working on those teams, these are exactly the sort of inquiries that you would undertake to see which of these variables has most effect, which ones are going to create lots of kind of conditional challenges in the race. So we didn't do it. We would have liked to do it, but it's a great question and something that you would do if this was a real case study.
Okay, great. Thank you. Another question. Well, this question about MATLAB, it's not really for you because you do not work with. Great. We have another one for you. So great presentation, Andy. And how did you choose the normalization range for parameters, and did you rank them by the significance?
So this is going to be a terrible answer. Obina did that, and I don't know what he did. It will have been accurate. It will have been it will have been compatible with statistical legitimacy. I'm absolutely sure. It might be in the audience today, but I don't know. But it would have been a tried and tested method. So sorry, I don't have a better answer than that. But and not to delegate responsibility, but I didn't do it, so I'm sure it would have been correct.
Okay. We can maybe share this question with you later, and if your colleague will be available, I can
absolutely
respond. Yeah. Okay, great.
Let me also just give another thumbs up to raw graphs. I use raw graphs a lot, and it's great to see that Giulia used it. So yeah, it's one of the most accessible sort of free to use tools that are out there. You don't need any sign up or accounts or knowledge. You just have to prepare the data elsewhere, bring it in, download the SVG or the PNGs and finesse them elsewhere. But yeah, thumbs up for that one.
Okay, thank you. We do not have more questions for you. We still have some questions incoming, but they're more about challenge itself.
Sure.
So in any case, if we have more questions for you, Andy, we will share them with you later.
Of course.
And we'll provide a post-event report for participants. So thank you again, Andy.
My pleasure. Thank you very much.
Thank you. And now we will move to our third and last use case, which is going to be a video, actually, because as I said, mentioned before, Chiara Phillips, she wasn't available for online session today. So we will share a video with you. And again, if you have questions, don't hesitate, please. We will share them with Chiara. And again, the post-event report will be provided to you with all the answers. So Florian is preparing a video for you.
Yes, and I have troubles.
Oh no.
Sharing the sound that Zoom doesn't let me. We will share the video on the website in the resources tab again, so that you can check what Chiara presented for this year's event. We are very sorry for this technical issue, that we are not really, we don't have much things we can do about it. I will now present the Dataviz challenge in more details, because we had a lot of questions on the challenge. So hopefully this will give you a bit more insight on what is it and what we're expecting. I will start sharing my screen with no sound. We don't need it. There you go. So as I said, I'm going to present the Dataviz challenge in more details. So we're now reaching the end of day one, a bit more prematurely than expected. Day one was mainly about inspiration, so discovering the Copernicus Marine Service, seeing how designers approach ocean topics, and getting ideas also for you and your visualization. What I'd like to do now is explain what happens next, how day two fits into this journey, and how the Dataviz challenge works in practice. So the challenge in one sentence is create a data visualization using Copernicus Marine data to make ocean science understandable, visible, and impactful. It is open, free, and requires no prior Copernicus experience. It is more an invitation to use the Copernicus Marine data as raw material for visual storytelling. The goal is not to produce scientific analysis, but to create clear, engaging, and meaningful visualization that help broader audiences understand ocean phenomena. Day 2 is designed to lower the technical barrier as much as possible. So you'll see how to explore the Copernicus Marine data, how to work with it using different tools, and how to move from data to a first visual output. This is also when the challenge officially starts, but you'll have several weeks to work on your submission. As we presented, the deadline is on June the 19th. So please join us on 9 April at 10 a.m. CEST by visiting the event webpage, just like you did today. In terms of timeline, you will have until June 19th to explore data, test ideas, iterate, and submit your visualization. As mentioned before, the visualization can be static, animated, or interactive. The winning design may be in any of this format. In any case, it will be adapted in consultation with the designer, of course, for the cover of the Ocean State Report. And after the submission deadline, selected designs and their creators will be showcased on Copernicus's social media, channels, and website, which are visited by several thousand people. Just a quick word on rights and rules, because we want everything to be very clear. First of all, you keep full ownership of your work. This is extremely important to us. By submitting a visualization, you simply allow the Copernicus Marine Service to display and share it in the context of the Dataviz challenge and the ocean sessions, always with clear credit to the author and without modifying your work unless you explicitly agree. Team submissions are welcome. Proper data attribution is required, and you will find the full terms available in the submission process. But the slides cover the essentials. Again, for the team submission, we will only need single contact point, but you can be as many as you want in a team. Practically speaking, we know that Copernicus Marine data may be new to many of you. That's why we created a resources section on the event website. This is a curated space where you'll find explanation about ocean topics, tutorials to access and download data, guidance on formats and tools, and concrete examples of data visualization. So you don't need to know everything up front. This section is there to support you at every step. And it will also be made up to date following the questions you have so that it's as full as possible for you to participate in the challenge. And the second key page is the challenge rules and participation section. This is where all the practical information lives, which data sets you may use. Just note that you are not restricted to the data set provided. You are free to explore the Copernicus Marine catalog and find a story you want to tell. We just selected a few data sets that are already downloaded and ready to use for those of you who want to use this option. In this section, you will also find how to submit your work, which formats are accepted, which tools you can use, and what the timeline looks like. So if you ever wonder, am I allowed to do this, or how do I submit, this page is your reference. Just to be very clear, we're not looking for scientific perfection, as I said, or highly technical workflows. What matters most is clarity, storytelling, and visual impact. So show us how you interpret the data and make it meaningful for others. So surprise us. And we invite you to share this webinar and the challenge widely so that Copernicus Marine data can reach new audiences and spark even more powerful visual stories. So now, if you have any questions, I think we have a bit more time then to answer the questions that you have on the challenge. I will, maybe you just keep seeing my screen if I put it like this. Yes. We will take a few questions on the Dataviz challenge. And again, we will do a post-event report where you'll have all the answers you need for the challenge, and we'll update the website also with the answers. Yes, I can match myself with a question. So the first questions we have is, do we have to present our work or just pass it? So for the Dataviz challenge, you will have a submission form that you will find in the challenge rules and participation tab. Well, you just have to submit your data with a short description and the authors. You don't have to present it in any way. And after the selection, we may contact you to get more details or adapt it to our communication channels. The second question we have is, the challenge asks for one visualization, but it is a standalone. If it is a standalone piece disconnected from the content of the ocean state report, how can it tell the story without narrative text? Or do you mean by one visualization, it's a full page with narrative, graphs, and story, like the 2 pages on acidification? Your visualization can include texts and explanation, just like the 2 visualizations that we just saw for Giulia and Andy. And again, it will be accompanied by a small text presentation that you will provide. So it will be put in context. And for the ocean state report, again, we'll come back to you for adapting it to the cover. But the full visualization can be anything. For the challenge, do you have to use the ProViewer, or is it okay to use other JS software? You can use any tool that you need for the challenge, both scientific tools and visualization tools. The ProViewer is more here for you for visualizing the product, visualizing the product, and downloading the product or the data sets you need in terms of timeline or area. But you can use also any other JS software that you are used to, and any design software that you're used to too. Does the challenge policy require individual submission, or are team submission also permitted? So as I said, team submissions are permitted. You just need to define one contact point for each team. And there's no limitation in how many individuals can work in a team. If you are used to work with very large teams, you are very welcome to. But also individual submissions are allowed. Is there a specific theme for the challenge? As I said, you have a few data sets that are already downloaded and available through the challenge rules and participation tab. It is data sets on specific marine phenomena, so marine heat waves, ice extent, and so on. However, there is no specific theme on the challenge, as long as it's Copernicus Marine data and it focuses on the ocean. It doesn't have to be a ocean phenomena. It can be anything. Anything is accepted for the challenge. And as we said, it can be very global or very specific to a region. Do we have other questions? Is there a call to action the Dataviz needs to convey? Again, it depends on what you want to portray with the data that is provided. It can be a call to action, but it's not mandatory again. So it's ocean data and it's fit for the general public. If you want to portray specific phenomena, it's very up to you. Can I share my data visualization after the challenge is complete? Yes, and you are even invited to, you can already share it before the event deadline. Again, the data is freely available and open to all. So as long as you mention that it's from Copernicus, you can share it in any of your networks that you use. Are visualization required to constrain themselves to be provided data sets? There are obvious opportunities for connecting the global with the regional by mashing up with different data sets. Yes, as I said at the beginning of the session, the visualization has to focus on Copernicus Marine data, but it can be linked to other data sets to portray a bigger picture or have complementary context to the visualization. But the main data source and ocean data should come from Copernicus Marine. The next question is, we want the general public to engage, but is there a specific way we want them to engage? The idea of the challenge is to portray ocean stories. The idea behind it is to take raw data and transform it so that it explains the ocean phenomena and it brings awareness on the ocean, on how it's changing also with climate change and other human activities. So there are many ways to engage the public. It depends on what you have affinity with. It can be climate change, it can be biodiversity, it can be phytoplankton bloom, or marine heat waves, the ice extent, etc. Anything that is close to your interest, you can create from and engage the public on those specific topics. Again, the catalog is very, very vast, and you have a lot of variables that you can have access to. So don't hesitate to work on a specific subject that you have at heart. Where we can find examples of CMS promotional campaigns. You can find many of them on our social media, especially on LinkedIn and on Meta. Yes, I think that's all I can say. But on social media of the Copernicus Marine, you have a lot, and also on the YouTube channel of Copernicus Marine. What is the format for the design that we should submit? It can be any format, so JPEG, PDF, videos, and also links for interactive designs. All the formats are listed in the challenge rules and participation tab. And as I said, for the winning design for the ocean set report, it will be adapted in accordance with the authors so that it can fit a static version of the visualization. But the formats are very free. Also, the ratios that you can use can be portrait or it can be landscape. It's again up to you. It can be round, it can be fish shaped, as you want. And we will see with you for adapting it to the ocean set report later on. Are AI tools such as Midjourney allowed for the challenge? Yes, whatever tool that you are used to use, you can. And as long again as it's Copernicus Marine Service data and it's constructed from Copernicus data, then you can use any tool that you're used to. How many visuals can we send? The challenge is for one visual. It can also be a poster like Giulia presented, for example. But the visual should be individual. You can only share one file per submission. Are you looking for data visualization that is appealing, or would something grotesque also be considered if it's suitably attention-grabbing and informative? This is a very good question. It depends on your approach for data visualization. We are trying to reach the general public, so if it's visually appealing, I think it's a plus to grab the attention of the public. But if it shows a very interesting information or data phenomena and is attention-grabbing enough, as you say, then any visualization is accepted. Again, art and beautiful is a very philosophical subject that I don't know if we have much time to discuss today. But again, visualizations are very up to you and what you're used to do. How to convert your data sets into CSV. You have lots of resources in the resources tab on the website to explain the format, the NetCDF format, how you can convert it to the format that you're used to use. And on Thursday, we'll have a specific presentation on MyOcean Pro, how to download the data and how to convert it until you can use it in the tool that you're used to. So, but already today you can go on the resources tab and check the Help Center articles that are very detailed on how to convert the data, what about the format, and anything you need to know on the data format. Is there a guideline on how to add data attribution on the visualization? The only guideline is to, for the visualization, to cite Copernicus Marine Service and present where the data comes from. We will ask you to give us the specific product that you used in the submission process. So any product that you used to create the visualization, but it doesn't have to be portrayed directly on the visualization. For the submission on June 19th for the deadline, it's June 19th, at the end of June 19th, so I believe it's a Friday. So it's June 19th, 11:59 p.m. CEST for the time deadline of the design. Can we use SSP scenarios for the design? I am not sure I understand the question for this one, but we'll answer it in the post-event report for this. For the challenge, if we face the 180 degrees program in visualization maps, the visual errors that occur in spatial data routes or shapes cross the 180th meridian, also known as the Inter-Meridian International Date Line, how do we fix it? For the Copernicus Marine data, it is global, so there is no visualization issue. This 180 degrees program is depending on which tool you use to visualize it. So it's more a cartographic issue than a data issue. And there are many techniques that can be used to fix it. For example, recentering the map, choosing a different degree or latitude to create your map. But for the Copernicus Marine data part, it's fully an like global and consistent, so there is no data limitation for the 180 degrees problem. Sorry. There's a question on there's no data file in the resources tab regarding the target zone, which is the Bay of Bengal. How can I obtain similar data for the specific zone? So as I said, we selected a few data sets on the resources tab for the challenge, but you are welcome to use any other product or any other area that your data fits to and your interest fits. So I invite you to come on Thursday to the more practical session where we'll present the MyOcean Pro Viewer, so you'll know how to select a specific product for your area of interest and how to download the variables that you're interested to for the Bay of Bengal. Are entries restricted to those who are able to participate in the sessions today and on April 9th in person? No, so the challenge is open to everyone until June 19th. This session is more to give you a bit more of context on the challenge and all the rules and things that you might need to complete the data visualization, but this sessions are recorded and will be available later on. And we invite you to share the challenge within your network so that as many people as possible can participate if they want to, and so that the Copernicus Marine data can be used widely to share stories on the ocean. So it's not restricted, and you're invited to share it also with some colleagues. Do you provide resources for spreading the challenge on social media? Where can we get them? So far, we have a post on social media that you can share. We will put the link also in the resources tab. And yeah, if we have any other communication tool that we can that you can use, we will make sure that we put it in the resources tab or send you in the email after our session. Is it okay to make a visualization even if it's not global, like just focus in one region? Yes, again, it's not a criteria for a selection of winning design. Your visualization can focus on a restricted area or the global ocean, as long as it's marine data from the Copernicus Marine Service. You can do any visualization that is appealing to you. Is it okay to use machine learning or statistical methods for the visualization? Yes, you can use any tool that you're used to, and we are not expecting scientific perfection, but more visual stories on the ocean. So don't invent data, but you can visualize it as you want. And for maybe our last question, because we are running out of time, but we'll again answer all the questions in the post-event report. What are the standards for selection and what criteria are used? We are looking for nice visualizations on the ocean using Copernicus Marine data. It should tell a story on an ocean phenomena or an ocean variable. All the criteria are listed on the event webpage, but again, it's a very open challenge as long as it tells a story and gives more visibility to the ocean data, and the ocean phenomena, it can be high in the ranking. And with that, I think I just need to find my presentation again. Here it is. It is now time to wrap up this session. So one last reminder about replays and polls. You'll find both of these on the event website through the menu at the top of the page. We will also send you an email to let you know when the replay is available and a link to the poll about today's webinar. So if you liked today's session, and also if you didn't like it, please fill the poll so that we can improve our future sessions. And if you'd like to go further after today's session, I encourage you to visit the Copernicus Marine Service YouTube channel, where you'll find a rich library of webinars and training sessions from the past few years, all freely available. You can also discover all Copernicus Marine events, both upcoming and past, via the Events tab in the top right menu of the Copernicus website, where you can open any event page for details and registration. Having said that, all that remains is for me to wish you a lovely day and to say see you on Thursday for the practical session of the Dataviz challenge. Thank you, everyone.